Hey there, welcome back to the Game Dev Engineer Super Duper Study Sheet. Today we're talking about the cross product and vector line segments planes. So a lot squeezed onto this sheet, but we're going to get it done. So the cross product, also known as the 3D outer product or the vector product, is they're going to ask you what that is on the interview. They're going to say, hey, what's the cross product? And you're going to say, the cross product returns a vector perpendicular to two input vectors and scaled by the product of their magnitudes multiplied by the sine of the angle between them. Remember, I like to remember that it's the sine is the angle between them and versus the cosine, right? For the dot product, it's you multiply by the cosine between them. But I like to remember that it's the sine because the S kind of looks like two crossed curves. So that's how I remember sine for cross product. And then for the dot product, where is that? I lost it. Here we go. The dot product, the C in cosine kind of looks like a dot. So that's how I say cosine for dot, S for sine for cosine. Sorry, S for cross. S is a cross, so that's the cross product. There you go. Okay, so this is the expression numerically. You're going to do A cross B is equal to the magnitude of A and B multiplied by sine, and then you get this N here. And so N is a unit vector perpendicular to A and B. Okay, fair enough. And then the angle here is, of course, the angle between A and B. So the cross product magnitude is going to be 0 if the lines are parallel or not linearly independent. It's going to be equal to the area of a parallelogram formed by those vectors. So if you look at this diagram here where we've got vectors A and B, that area which they prescribe on the floor there, that is the that area is going to be equal to the result of the cross product magnitude. And then what else do we have here? Okay, so if the lines are parallel, okay, so I said that. And then if the lines are perpendicular, it's going to, the cross product magnitude is going to be the absolute value of A times the absolute value of B, which is the max. And again, you know, that's because on the unit circle, if they're perpendicular, they're at a 90-degree angle, and that's when the circle here reaches its highest Y value. So important to have that illustration in your mind. Okay, it's also anti-commutative. This is, I've definitely been asked this on interviews before. So they'll say something like, is A cross B equal to B cross A? And the answer is no, sir. It's actually it's collinear, but the thing is, it's going to be pointing in the opposite direction. So that's all you got to say. It's pointing in the opposite direction, which is called anti-commutativity. And it's also additively distributive, which might be interesting. There's also this curious thing called the triple product, which has no value for your interview. You're probably not going to be asked that. I just thought it was kind of cool. And then there is something where people will talk about norms pretty often. The P norm, just in general, right, is going to be expressed as this expression here, where you're going to have the summation of the absolute value of each individual item raised to the power of P, and then you're going to take the result of that and raise it to the power of 1 over the power of P. And so this is pretty common when people are saying something like, hey, you know, what's the 2 norm? And that's where we're getting to down here. But before I get there, I wanted to talk about this diagram here, which is the cross product actually written out. You're probably not going to do this by hand, but if you want to, well, if they ask you to do the cross product, you might have to do it for a 3x3. And so this is how you do it. I highly doubt they're going to ask you that. I've never been asked that. But this is how it works in case you want to, you know, reference it while you're doing your work. Okay, so let's talk about this part, which is the norms. So the most famous norm is called the L2 norm, or the Euclidean norm, also called the norm, or simply the norm. Euclidean norm. And it's also called the vector magnitude. And the way that works is you just plug 2 into this equation here, and then that's it. Okay, so any line may be defined by 2 points, where the difference defines the direction. Interesting. Yes. So basically, a vector, a line segment, and a line, they all follow this formula, which is essentially a starting point plus t times v. Okay, also expressed this way if you want to expand it out. But there's differences depending on if it's a vector or a line segment. What's going to stay the same is that p is always going to be the starting point, v is always the direction, and then t is the step size. But that if it's a vector, the step size is going to go from 0 to infinity. If it's a line, the step size is going to go from negative infinity to infinity because it extends in both directions. And of course, if it's a line segment, it's going to go from 0 to n. It's a set value. It's not going to extend for infinity like the vector does. But what's different between a line and a vector? Well, the vector is going to go for infinite in only one direction, whereas the line goes in two directions infinitely. Okay, wonderful. And then the last thing to talk about is the plane here. Okay, so this is actually a little bit complicated. So we're going to take our time with this because it's definitely a question I got wrong, and it is one of the reasons why I didn't get into a company I really wanted to get into. Okay, so you need to completely, 100% understand what each of these letters means in the plane equation. A, B, and C form a vector which represents the norm of the plane. D, divided by the magnitude of that norm, is the signed distance from the origin to this plane, the shortest distance from the origin to a point on this plane. So, this is going to come up later, but they might ask you, hey, how do you get a point on a plane? And that's actually a really hard question, and none of my friends can answer it because it's not intuitive. Because I would think, oh, you just take the plane equation, you plug in 0, 0, 0 for A, B, and for X, Y, and Z. That is 100% incorrect. What you do is you do what you do down here, which well, I don't know if I should explain it now or explain it later. I'll explain it later. Watch the next video to figure out how to do that because it's not what you expect. But something to keep in mind is that there's multiple ways to represent a plane. You can also represent it using this formula, okay? But you could also say just 3 points. That's all you need to define a plane. You could also have a point and two vectors, and that's actually called the parametric form, and it's useful later for several derivations. And then, of course, you can also say the normal and the origin. So this is called the normal implicit form, and that's where you have a normal times basically x minus the origin equals to 0. So in other words, this is going to be d is equal to negative n times the origin. So this is the normal implicit form, and it's just another way to represent this. We're going to be talking more in depth in this in the next video, so we'll start solving some problems where you need to use that. And then the next thing is, what does it mean if one of these values is 0? So they might say to you, okay, so you have a plane. Can you describe to me the geometric significance of a plane where d is 0? Well, that means it passes through the origin, right? Because d is the distance from the origin. But if a is 0, then that means that the plane extends parallel to the x-axis. And then if a and b are 0, then that means that the plane lies parallel to the x-axis and the y-axis, of course, by virtue of this axiom, but also that the z-axis is parallel to the plane's norm. So one other thing to keep in mind. Okay, so that wraps up a super lightning fast review of the cross product, the lines, the vectors, the line segments, and the planes. I hope this helped you on your interview. Good luck, and I'll see you in the next video.